Finally, in our Module 1.1 class notes in examples 7 and 8, we have another example of evaluating functions. And this time we're looking at a particular evaluation problem that, number one, doesn't have a lot of numbers to work with, more letters than numbers, and that can be challenging. So this is a good example to work. Number two, this example set, examples 7 and 8, illustrates some algebra that is very, very fundamental to the work that you will do in calculus when you get to your calculus class. Calculus is all about finding derivatives. If you have any experience with calculus, you may know that word derivative. If you don't, you will. When you take your calculus class, you'll see that pretty much everything in at least a first calculus course revolves around derivatives. And this is the algebra foundation. This example gives the algebra foundation for finding the derivative of a function. So this is really focusing in, laser focusing in on making sure that you have the arithmetic and the algebra knowledge to help you in calculus going forward. That's what I really like about these examples here. Note that there is a typo in the instructions. Here, there's just a parentheses x with no function name in front of it. There should be one. We should have an f in front of that x here. It's f of x equals x squared minus 16. I apologize for the typo. It happens sometimes. But the instructions here are to evaluate the function f of x equals x squared minus 16 at the indicated values. And in question number 7, we see we're looking for f of a plus h. And this is, it looks different, perhaps, but it's really no different from the examples that we worked previously in this module, where we were given an input value and asked to work out the output value. Here it's just, instead of a number input, we are given an expression input. We're asked to go back to the function and input a plus h. We're going to plug a plus h in place of x. And here's what that's going to look like. Instead of x squared minus 16, we will have a plus h squared minus 16. That's basically what we're looking at here. That's as simple as it is. I know it's letters, more letters than numbers, and that can be a little bit challenging to students, and I totally get that. But if we just see, well, this is just an input-output scenario. I'm inputting a plus h, and then what I get out is my output, my answer, then it can be as simple as that. Now, we do want to simplify and expand and reduce our answer as much as possible, and I'll do that by squaring a plus h. Just be careful that when you square a plus h, you are multiplying a plus h times a plus h, which means that you're going to FOIL. And first times first is a squared, outside is ah, inside is ah, and last is h squared, so that correctly you get a squared plus 2ah plus h squared minus 16. From there are no like terms to combine, no more operations to perform. So that is, as complicated as that answer is, that is the answer, because I can't simplify it any further. Now what we want to do is take that result and apply it in our next problem, which is f of a plus h minus f of a all over h. And then the note here that h is not equal to 0 is important because we can't divide by 0. So h can't be 0. True, we can't divide by 0. But that note that h is not equal to 0 isn't going to play into our work that we do. So it's an important note to verify that we're not dividing by 0, but it's not going to actually, for practical purposes, it's not something that we're going to use to work the problem. All right, so we'll leave that there, and we'll just focus on f of a plus h minus f of a over h, which actually has a name. We utilize this fraction very frequently in calculus, as I was saying a few minutes ago, and we call it, because we get a lot of use out of this fraction, we give it a name. We call it the difference quotient. It's not a very creative name, because it's just there's a difference, there's a subtraction, and then there's a quotient, there's a division. So we have a subtraction and a division. We call it the difference quotient. So when you get to calculus and they start talking about difference quotients and limits of difference quotients, you'll note that this is the operation that they're coming back to. So let's see how do we work this operation. One piece at a time. One piece at a time, and let's make sense of what I have written on the right here. Note, question 7 gives you one of the pieces that's going to get you to your answer here. F of a plus h is exactly what we calculated in question number 7. So I have exactly that, a squared plus 2ah plus h squared minus 16. I have that in my work for question number 8. So we don't have to rework that. Let's use the answer that we already got in question number 7. Let's utilize that work and let that help us work out question number 8. So f of a plus h then is a squared plus 2ah plus h squared minus 16, as I've already found. And then let me switch colors here and say, then f of a is the function f, where I go to the function f and I replace x by a. So instead of x squared minus 16, that's a squared minus 16. Don't let all the variables and letters and lack of numbers confuse you too much here. It's inputs and outputs. That's what we're looking at. So if f of a is a squared minus 16, as I've got here underlined in orange, then we've got this relatively complex looking fraction, but things start to work out from here. I'm going to subtract these two sets of terms, and when I do that, I note that a squared minus a squared, those two terms cancel. And similarly, negative 16 minus negative 16, those two terms cancel. And all I have left are the two terms 2ah plus h squared, still over h. Now I don't have any more like terms, but I do have a factor that will reduce. I see a lot of h's in this fraction. The next step that we're going to take is to factor an h out of the numerator. If I factor the common factor of h in the numerator, then I've got h times just 2a plus just 1h. So h times 2a plus h all over h, and now the h factor in the numerator reduces with the h factor in the denominator, and I have left 2a plus h. I don't have any more fraction, I don't have any more operations, no more like terms to combine. That then is as far as I can reduce my answer, and it actually reduced pretty well down to the relatively simple 2a plus h. That is the answer. We are done with this problem, And I just want to come back one more time to say what we just did basically we're one step away from finding the derivative of a function. And calculus is all about derivatives. So this work that we just did, if you see the flow of this work and understand how to work a problem like this, then you are literally one step away from doing calculus. That's huge. You're getting prepared to work on calculus and derivatives. I like calculus. I'm excited.